Equivalence relations and partitions of a set. A relation on a domain is a set of pairs of elements of the domain. For example, x is less than y on the set of real numbers. Another example is x is equivalent to y mod 5, a set of integers. But relations can also be defined by specifying a set of ordered pairs of elements that are related to each other. For example, a relation on the set of complex numbers would be specified by the set of pairs z1, z2, or it can be specified as z1 is related to z2 with the condition we therefore can use either the notation xry or the pair xy is in R to express x is related to y.
For this video, I'm going to stick with the notation xry.
A relation is reflexive if x is related to x for all x in the domain. If we plot the set of points on this relation, we will see in a reflexive relation that all of the points on the diagonal are included on the plot, and maybe some others. A relation is symmetric if x is related to y implies y is related to x. If we again plot the points of this relation, we see that the points above the line x equals y are a mirror image of the points below the line x equals y. A relation is transitive if x is related to y and y is related to z implies x is related to z. I showed visually what this looks like on a relation with 3 points. Visually, this is more complex to check because we need to verify that a ray tracing condition holds. If we take a domain and divide it into pieces, this is known as a partition. We can define a relation on the domain by declaring that x and y are related if they lie in the same subset of the partition. It is easy to check that this relation is reflexive since every x is in the same set as itself. It is symmetric since if x and y are in the same set, then y and x are in the same set. And transitive since if x and y are in the same set and y and z are in the same set, then x and z are in the same set.
We call a relation an equivalence relation if it is reflexive, symmetric, and transitive. Because the relation is reflexive, every row and every column of a plot will have at least one element because the plot contains at least a diagonal. An important property of equivalence relations is that the sets related to a given element partition the domain. The reason is that if two columns share an element, then they must be equal. If R is an equivalence relation, then we let R of x be the set of elements which are related to x. We claim that the sets R of x partition the domain. That is, every element is in at least one set and only one set. We've already discussed why each element is in at least one set. Next, show that if two sets share an element, then the sets are the same. Assume that there is an element w in both Rx and Ry. Then there is a z in Rx, then x is related to z, so z is related to x. By transitivity, z is related to w, so w is related to z, and y is related to z by transitivity. Therefore, z is in R of y, and R of x is a subset of R of y. A similar argument shows that R of y is a subset of R of x. So R of x and R of y are equal. We've shown that if R of x and R of y have a common element, then they are equal. Therefore, the sets R of x cover the domain with no overlap.